All right, so let's see how this works. So perform the indicated operations. If the matrix does not exist, write impossible. All right, so when we add and subtract matrices, we just add and subtract each corresponding element. Okay, so let's call this matrix A and let's call this matrix B. And so this would be A11, row 1, column 1. This would be row 1, column 2, row 1, column 3, and so forth, right? 2, 1, 2, 2, and 2, 3. And this would be B11, B12, B13, B21, B22, and B23. So all you're going to do is just add each element to its corresponding element, each element in A with its corresponding element in B. So A11 is going to get added to B11. So 5 plus 9 is 14, right? And then A12 is going to get added to B12. Negative 1 plus 9 is 8. And then A13 and B13, 2 plus 2 is 4, right? Same thing in the second row. A21 and B21. 1 plus 4 is 5. 8 plus 6 is 14. And negative 6 plus 4 is negative 2. And that's it. So pretty simple to add matrices. That's all there is to it, okay? Now, one thing that has to be true is in order to do this, we have to have all the same corresponding elements, right? So in other words, our dimensions have to be the same. We can only add matrices when their dimensions are the same, okay? A 3 by 2 by a 3 by 2. If this were not a 3 by 2, then we wouldn't be able to add it to A because we wouldn't have all the corresponding elements to add, all right? So when you add matrices, their dimensions have to be the same. The same when you subtract, because it's the same principle, the same idea. So for 2 here, when we subtract, we're going to do the same thing. We're going to do A11 minus B11. So 8 minus 0 is 8, right? Then we're going to do A12 minus B12. So it'll be 3 minus negative 7. So that's going to be 3 plus 7, which is 10, right? So we had a minus negative, so that turned to a plus. Then we have negative 1 minus 6, right? So that'll be negative 7. Negative 1 minus 6 is negative 7. And then finally, we have negative 1 minus 2, which will be negative 3. Okay, and so that's our resulting matrix. All right. So when you add and subtract matrices, all you do is just add and subtract their corresponding elements, and then you whatever. So first of all, your dimensions have to be the same. So here we had a 2 by 2 and a 2 by 2. And your resulting matrix is going to be the same as well, right? So if you combine a 2 by 2 with a 2 by 2, you're going to end up with a 2 by 2, right? If you combine a 3 by 2 with a 3 by 2, you're going to end up with a 3 by 2 when you add and subtract, okay? And we'll talk about next lesson. Multiplication is a little different, but with addition, subtraction, and scalar multiplication, you end up with the same dimensions as what you started with, okay? So let's take a look at number 3. Number 3 is different because here we have a 1 by 3 and a 3 by 1. And this doesn't work. We have an A11 and a B11, but we don't have an A12. We have a B21, right? And we have, instead of a 13, we have a 31. And so we can't do that. So that's where impossible comes in, okay? So here we're just going to write impossible. Okay, or you can write does not exist. I've seen before, DNE. All right. So anyway, so that's addition and subtraction. Pretty straightforward. And if the matrices don't have the same dimension, then you can just write impossible. All right. Now scalar multiplication, number 4. So this is also pretty intuitive. if I'm multiplying a scalar, a number, right, just a constant like 3 to a matrix, all it is just the distributive property. So I'm just going to distribute this into each element of the matrix, and so it'll end up being same dimensions once again. So it'll be 27, 12, -9, and that's it. All right, so hopefully all that makes sense, and it's pretty straightforward. Next slide, we'll see a mix of different operations. So we'll see scalar multiplication with addition or subtraction.